All right, so we are back now looking at formulas, which are a type of equation that we use to regularly to get a predictable kind of answer. How's that for a definition? I'll explain what I mean. We use a formula to find the area of a circle. So the area of a circle formula is area equals pi r squared. So that formula stays the same, and then whenever I need it to find out the area of a circle, I take it, say area equals pi r squared. Okay, what information do I have? Well, I know that r, the radius, is 3 centimeters. Plug that information in, and I get out an answer that will give me the area of a circle. Similarly, we have formulas for things that are more physics or science related, like the formula that we use to change degrees Fahrenheit to degrees Celsius, and here it is. Celsius degrees are equal to 5/9 times the quantity of Fahrenheit degrees minus 32. So in other words, if I had 0 degrees Fahrenheit, I wanted to know what that is in Celsius, I would plug the 0 in. I would subtract 32 because it's within the parentheses, and that's our order of operations. Then I would take that number, which would be negative 32, multiply it by 5/9, and whatever I get as an answer, that is the degrees Celsius, right? 0 degrees Fahrenheit, whatever number I get after I plug it in is going to give me the degrees Celsius. Now that is useful to us, but sometimes when I have a formula, I want to rearrange it so that it gives me different information. So right now, this is a formula that gives me an output, means our answer, that's in terms of Celsius. Right? Whatever I plug in for Fahrenheit, it's going to give me an answer in terms of Celsius. But let's see how we could rearrange this formula to create an output of Fahrenheit, which really means simply this. We want to get the F isolated. So we said before that when we want to solve an equation, we want to isolate the x or isolate the variable, meaning get it by itself. Right now, that's what we want to do. We want to figure out how to get the f isolated, or the f by itself. So let's see how we can use our rules from equation solving to achieve this end. So the first thing we want to do, we want to think about this, remember, in terms of a package where you have like a present within a present within a present within a present. We want to go to the outside and unwrap it first, and then we want to unwrap the next layer and unwrap the next layer until we get down to the center, which should be our variable that we're looking for. So let's decide by looking at our equation here. We're solving for f. That's the center present. Let's look around it. What's the layer that is on the outside of our f? And I would say it's this. It's 5/9 times all this stuff, right? This is kind of the outside present out here. 5/9. We're trying to multiply. We want to get rid of that. How do we get rid of a fraction? Well, multiplying by a fraction it's kind of like we're multiplying by 5 here, and we're dividing by 9. That's technically what we're doing. So we're multiplying by 5, and we're dividing by 9. So if we want to undo that, we want to multiply by 9, put it on the top, and divide by 5. So I want to multiply both sides by what we call the reciprocal of the fraction. So we have the fraction 5/9. I want to multiply both sides by 9/5. So 9/5 times both sides of the equation. What happens when we do that? Well, on the left side of the equation, let's put our line down here. Just keep the sides of our scale separated. On the left side of our equation, we end up with 9/5 times c equals. On the right side of our equation, when I have 5/9 times 9/5, they basically cancel each other out, right? 9 and 9 cancel out, 5 and 5 cancel out. 5/9 times 9/5 is just 1. So these just get rid of each other. We have multiplying by 1, which doesn't do anything. So that gets rid of the fraction. And we're left with just f minus 32. We ask ourselves, is f isolated? Is it by itself? And we would say, no, it's not, because we still have this minus 32. How do we get rid of the minus 32? Well, to get rid of a subtraction term, we want to add. So we add 32 to get rid of it. But whatever we do to the right, we have to do to the left. So we're going to add 32 here, which is going to give us on the left 9/5 c plus 32. We don't need any parentheses or anything tricky over there, because it's just we're adding 32 on to the end of the term. And then over here, we're left with just f. So is f isolated? Yes, it is. It's all by itself. So we have answered our question. Now, I like to write formulas with the isolated variable on the left. This just looks kind of backwards to me, having all the stuff on the left and then the f on the right. So I'm just going to rearrange it. I'm not going to do any math, but I'm going to put the f on the left-hand side, and I'm going to put 9/5 c plus 32 on the right. And that, that is our rearranged formula. So I'm not actually teaching any new steps. I'm just showing that we are using the concept of solving equations to get a answer that's not numeric. I guess that's what makes this different. In the other section, every time we solved an equation, we got like x equals 7, or x equals 1/2, or x equals -3. Each time that we solve for a variable, we are getting a number as the answer. X equals a number. In this case, we're not getting a number as an answer. Our answer still has variables in it. And that's okay, because in a formula, we might not have all the variables turned into numbers. Like in this case, Fahrenheit and Celsius, we want to keep the F variable and we want to keep the C variable in our formula. All we wanted to do was rearrange it. It's like taking the furniture in a room and we keep it all in the same room, but we're going to put it all in different places. Same rules apply, whether we're solving and getting a numeric answer, or we're solving and getting an answer that includes variables. Okay, we're going to put that aside. We'll talk more about that in class. This sometimes can be tricky for people to try to wrap their minds around. It just seems like there's too many letters involved, so we'll be practicing it. So don't worry if this is still a little bit like, oh, I don't like working with formulas. The next section that we're going to talk about is absolute value, so let's take a look at that.